So one of the things that we can do, particularly around the miscellaneous category, if we're not quite sure, if we're on the fence a little bit, is to maybe put in some sort of caution around it. So if we create a new web filtering policy and we specify my location as Lee Lab, clearly in the real world it could be wherever you like. And one of the things we do is go into categories, type miscellaneous, select the miscellaneous category, and we're going to scroll down, and this time I'm going to set it to caution, not block, not allow, but caution, and we'll just take a look at what that does. And this is generally an approach I take anything we're not sure about. So let's go back to our victims machine. Let's change to the victim. Internet Explorer open. Let's create a new tab and let us go to HTTP. Kali, there's the domain already. So, and let's just make sure we're on the right port numbers for my own sanity. And you can see that Zscaler's kicked in, picked up this miscellaneous category this time, and it's prompting us for that continue. Now, by virtue of doing that, with a user at the other end of this, that works brilliantly. But it's also counter, it's blocking our communications that we have on our Kali device. Now we've had the caution page for the miscellaneous category. Let's go ahead and rerun our initial attack and see what happens from the attacker's point of view. Notice we're not prompted for the macros this time because we've already accepted and said yes. I'm going to run it manually anyway just to be thorough. We'll probably get some crash text over here. So we've now got our listeners. Like we had before, our port 80 listener is receiving nothing. And the reason for that is that we've put in that caution page. So anything that we're suspicious about not only prevents the users from potentially viewing suspect content, it inadvertently is preventing my communication and my command and control here. It's just one little demo that I use, and we can just retest that if we want to. We go to policies, URL, let's just remove the caution page, let's just delete it. Let's say yes to activate, go back to our attack machine, and let's reopen the document. Just let that run. There's our finances document, and we can rerun the macro. Drop them to Kali, and you can see the connection's back. So we're now back into that host. So now let's dig around some more inside the logs. So one of the overlooked and underrated features on the portal is the DNS insights. I typically use this during proof of concepts, to illustrate traffic flows and things like that aren't just web browser based. So what happens if I was to use that attack that we've just described there over something like port 53, which a lot of customers will just allow out, and indeed I could create a communication channel just to get around most firewalls and things like that to do that. So what I've done then, I've gone to analytics and DNS insights. This is only available with the cloud application firewall module, next gen firewall module, depending on what your terminology. I'm going to go back the last 5 minutes and do the same thing again, apply filters. You can see all the DNS entries coming thick and fast. So what I'm going to do is draw that back again to location Lee Lab just to filter out some of the noise. And what we're looking for here is, just like we did with the web logs, is DNS entries that are going to suspicious or miscellaneous categorized domains. So we've got miscellaneous there, as you can see, and that is something that maybe I'm interested in. And again, you can see it's hitting Kali. So armed with that information, I mean, I could filter that down. Domain category. Let's go and put in miscellaneous. Hit apply. Okay, so there's our hit there. We're just looking for that. See, I'm hitting the Google servers. Armed with that information, we can then go and create some policies around that. So then if we go down to DNS control here at the bottom, we can then start to create DNS-based rules for our users that will stop things like ports and protocols that maybe aren't going through the web filter. So again, let's say let's create this for Lee Lab, and I want to leave that as it is, for example, but I want to block, or I can redirect. So this is quite useful as well. We can send that to some sort of packet capturing engine, TCP dump, to see who on the network is requesting this information. But if I click block and then, scroll up, go to destinations, and one of the things we can do is where it's got the requesting domain is type in miscellaneous. Hit done. So now blocking that traffic from that that location, anything that's resolving miscellaneous. Click activate, go back to our attack victim, and let's resolve again. Now because we are trying to use the Google resolvers to capture that domain, you can see it's hanging. We are not allowed to resolve that, and in fact we're going to get a timeout when communicating to those domains. So again, another little tune that I show customers using that database. And this will work for things like pornographic content, file sharing. So again, if we go back to the portal and we want to stop things, applications that are not purely web browser based, for example, create a DNS rule. Okay, going here, and we're going to change miscellaneous to something like let's do, say, peer-to-peer would be more appropriate, and whack in peer-to-peer. So now any of that sort of activity at DNS level, on the domain level, is also going to be picked up, not just on the web side of things. So let me just roll that back and apply our changes. One of the other things that I often see as well is where customers simply allow DNS resolution to go out to the internet to any resolver. And typically when you speak to them, they have Google or someone like that set as their upstream resolver. And the problem with that is they're not locking anything down. And so one of the things I will typically do with a customer is if they had a malware infection, let's say the attack I've just shown you, and I wanted to set the DNS server on that host, which is entirely possible, to my own DNS server, so that when users browse to Yahoo and all these sorts of things, I'm intercepting that and sending them to my own version. So I could send them to a spoofed web page, for example. One of the things I quite often do with my customers is set a DNS enforcement policy. So we'll set an application of, say, DNS, and we'll just set that one. We'll allow the services to be any, but we can specify a service of DNS, and that will basically lock down the application of DNS against the port of UDP 53, for example, that will allow that through. And I'm going to say I want to say the destination is only 8.8.8.8, and we're going to allow that. We have that policy there, and then I can go ahead and drop a denial. So maybe change this to a block and drop below. And what that's going to do is force all those users to use the Google DNS servers and not pick and choose. So just making that attack surface a little bit neater, a little bit more finite.